In this work, we propose an end-to-end tool for designing, optimizing, simulating, and fabricating multicopters. This problem is challenging because the performance of a multicopter depends on both its geometry and controller. Using our system, users design vehicles by composing parts from a database of components. Each component has a set of parameters that control geometry changes and are further constrained by the composition tool. We propose an algorithm for simultaneous optimization of multicopters given user-specified objectives, such as payload, battery life, cost, as well as any combination of them. Users can then verify the design result with an interactive simulator of the dynamic system with optimized controller and geometry. The output of the system is a complete fabrication plan that includes a controller, electronics, and a list of parts required to assemble the geometry. A typical copter can be assembled in about an hour. We evaluate our fabricated multicopters by real flight tests. Our system handles classic designs such as the symmetric quadcopter with a 3D printed frame. We also experimented with a symmetric design of a copter with 6 propellers. In addition, our system handles complicated free-form geometry like this bunny-shaped frame with 4 propellers with different heights and sizes. Here we show a comparison of 2 quadcopters where one of them has been optimized for a longer flight time. With an upper bound on the width of the copter, our system suggests scaling the quadcopter in the other direction to allow for larger propellers. We gain over 10% flight time with the optimized design. This example describes a Pentacopter with optimized design for payload. We show the changes of shape and propeller orientation with iterations of our optimization algorithm. It is challenging to design a controller for a Pentacopter as it has an even number of motors. By using the LQRL controllers suggested by our system, the Pentacopter can take off, hover, fly to a target, and land reliably. The optimized Pentacopter has 30% increase in payload. Note that this Pentacopter is even harder to control than the previous one, as all of the motors have been tilted from straight up direction.